So hey guys, welcome back to another lecture on vectors. So as we discussed in our previous lectures, so what do you mean by a linear algebra and its all usage in our machine learning? So the linear algebra is just all about the study of lines. So what is study of lines? So as we go brief into the concept of vectors, you're going to understand. So what do you mean by a vector? Just an array of numbers. So vectors are just a array of numbers. So what do you mean by vectors? Vectors are just a array of numbers. So what do you mean by array? So this is called as array. From starts from the one point and tells the direction to the another point. So vector is a specific quantity as a line segment which has an arrow which has an arrow ahead. Okay. So vector shows the direction. It shows the direction. It shows the direction where we have to go. So it shows the direction like where we have to go to get something like. Okay, you can understand in that sense. Okay. So the vector, it can be defined as its magnitude or the length of the line of its direction. Like this is a vector. So how you can define this one? How you can define? So to define that, we have something known as called as magnitude. So what do you mean by magnitude? What do you mean by magnitude? It's just a length of the vector. So we're going to find. We simply have something. So we simply find the magnitude of this vector or the length of the vector by using the Pythagoras theorem in just a few minutes. Okay. So we denote a vector. So we can denote. So we denote our vectors. So we denote our vectors as like this, like this. So it's just a arrow on the top of his head, and just a line, just a small case, and with a bold. We use only small. We use lowercase. Okay, we use lowercase and bold. We use lowercase and bold. Okay. So there are two kind of vectors. So we going to discuss, like, there are two kind of vectors. So yes, they as I said, like, there are two kind of vectors. There are two kind of vectors. So there are two kind of vectors, like, which is a positive vector and a negative vector. So as you can see graphically and easily with this example. So like, you may ask, like, how we can denote like this. Since our school days, like, we have this kind of, like, this kind of path, which simply denote, like, if there is a negative relationship, then it is called as a negative vector, and if it goes positively, then it is a positive vector. I hope you understand, like. So as I said, like, the positive and the negative vectors before, like, so the more than 90%, so more than 90% of our problems deals with the positive vectors, more than 90 to 95%. Okay. So after that, we're going to come with just a new topic out there. So like, after doing that, we're going to come with a new topic. This, like, this is called as a origin, where the 2 point intersect in a 0 comma 0 comma 0. So 0 comma 0. There are two kind of vectors, like, a vector starts from the origin and starts from elsewhere, from a point, from end point to, from a starting point to a end point. These are the two kind of vectors. These are the two kind of vectors. So what are these vectors? So it starts from the 0 comma 0. This is called as origin. So it starts from the origin and goes it starts from the origin and goes along with the along and it goes along with the direction. And this graph over there, it starts from the it didn't in this graph, like, it didn't start from the origin. It starts elsewhere here, something point like a comma a and b comma b. and b comma p. It starts from a and it ends a, and it have a positive vector. Okay, so how, and this from the starting point is called as initial point. The starting point is called as, so that starting point is called as initial point, and the ending point where it ends like it, this is called as terminal point. So this is called as terminal point. So it is called as initial point, and this is called as terminal point. So I give you a simple example to understand you better. Okay, so yes, like I want to give a simple example. Like, so if I was there, like Tarak was there, and he wants to move from his home, and with it shows the direction, it shows the direction. This is called as vector. This is called as vector. It shows the direction from where I have to go. So it shows the direction from where. So it shows the direction for from where I have to go, from home where I have to go. It shows the direction. This is called as vector. So it starts from the origin. Okay, this example relates to this this example relates to this. Okay, so and we're going to come this example. It's a very interesting, like, so the Tarak was there. So he didn't start from his home. Okay, he started from the ground. So he started from the ground, not from the home, and he went to his destiny. Okay, this is one example. And and he need not to start from the ground. He may he may go to park, and then he starts from the park to his destiny. It also shows the direction. This is a vector, and we use this is called as which starts from the origin, and this a is called as initial point. A is called as initial point over there, and destiny is called as terminal point. Over here. And after that he comes from A to B, and here the B is the starting point now, and the B is called as initial point, and the destiny is called as a terminal point. Okay, I hope you understand with this example. So after completing that, I'm going to cover what is operations. So after completing that, I'm going to cover the operations of vectors. So we have addition, subtraction, multiplication, and we have a something known as scalar vector multiplication, and we're going to discuss a lot more as we go further. So first of all, we going to cover the addition. So the addition of vectors. So the addition. So the addition of vectors. So as in our school days, like, we are familiar with the addition. Like, we have example, and we just simply add these two numbers, like 1 plus 2 is equal to 3, 2 plus 4 is equal to 6, etc. Like, so we just simply add these numbers in our since from our school days. So with the same with the vectors also. Like, if I have a vector if I have a vector like this, and we just simply add these two, like we are adding these two. We just simply add these two, and we simply get like 1 plus 2 and 2 plus 3 over here. So we directly add these. So we directly add 1 plus 2 is equal to, we simply add 1 plus 2 is equal to 3, and the 2 plus 3 is equal to 5. This is the addition of vectors. So I can explain with another example, like if the value is 5 and 10, and the b value is 2 and 6. Just is a dummy example, and we're going to cover the a plus b. So this comes like 5 plus 2, and then 10 plus 6. Then it is going to be 7 and 16. So this is our addition of vector. So this is our addition of vector. So in a geometric sense, like there is a vector a and there is a vector b, we just simply add these two vectors and become a big vector, which is a plus b. So after completing the addition, we're going to come with something known as subtraction. We are very familiar with these two kind of things. Like we have a very familiarity since from our school days, like 3 minus 2 is equal to 1 and 5 minus 3 is equal to 2. Same with these as addition vectors, addition of the vectors, we simply just subtract. Like if it is a vector 2 3 and then b vector, as example like 1 1 1 1, then if I subtract these two, then it become like 2 minus 3 minus 1 and 2 minus 1, then it is become like 2 and 1. So I hope you understand. It's just nothing, like it's just not a rocket science. So in a geometric sense, like if there is a vector and there is a b vector, if a minus b, then it subtracts some amount of area. It subtracts some amount of area from if we are taking something from a, we are taking something from a, and this is that something which is 2 comma 1 in that 2, which is 2 and 1 in that example. So we're going to cover something known as scalar vector multiplication. So sorry for that. Okay. So so what do you mean by scalar? So what do you mean by a scalar? Scalar is just a number. So scalar is just a number like 1 comma 2 comma 3 all the way to etc. It's just a number, and we simply multiply with something, no, something vector, and we get our output. It's just as simple as this. For example, I give you some simple example, like we have a 2 over here. So the scalar is equal to 2, and we have a vector v, which is 2 and 3, as we simply multiply with the scalar, then we're going to get, as we simply multiply these, then we're going to get 2 into 2 and 3. We simply multiplying this with both the, and then we're going to get like 2 into 3, 2, and we're going to get 2 into 2 and 2 into 3, and we're going to get 4 and 6. This is our scalar vector answer. Okay, I hope you understand. Like there is nothing over there. With scalar means it's just a new word for you. But scalar, just remember the scalar means just a number which we used to multiply the vectors and also the matrices we're going to cover in our next lecture. So I hope you understand. So after that, we're going to cover something known as transpose. It's just a new word for you guys. So what do you mean by a transpose? So transpose means, by the word you can understand, like transpose, it's just transposing its form, its body. Like in our vector, in our vector sense, in our vector sense, we use transpose if we have a column vector over there. So we have a column vector over there, and just by applying the transpose, it become a row vector. It just transpose its body from a column vector to row vector. So so many students have a confusion between the column vector and a row vector. So row is just a row. Just simply remember, like a row means a vector. Okay, is don't like the row is equal to vector. Just as a simple that you can remember, like, so what is row? Row is like a vector which is in horizontal. Okay. So what is column? So what is column? Like it is in downside, this this. I hope you understand. Okay. So I hope you understand. So I hope you understand. So what do you mean by transpose? It makes rows into columns and the columns into rows. It just makes rows into columns and columns into it just make into rows into columns and columns into rows. So they are another vectors like the unit vector. They are another vectors like unit vector. So any vector whose length is 1. So it's just a unit vector means if the vector has a length of 1, then it is called as a unit vector. And we also have something known as zero vector. So if any vector whose length is 0, then it will become a zero vector. As simply like the length of the vector is 0 and the length of vector is 1, and this is called as unit vector, which has some kind of unit out there, and if it has a 0, then it is called as zero vector. It has a zero vector. So after that we're going to cover something known as magnitude of the vector, as we discussed before, like magnitude of the vector. So how we find the magnitude? So yeah, how we find the magnitude of the vector? So I just draw a graph over there. So just a vector over here, it starts from the origin and it has a positive direction. It has a positive direction, positive vector. So how we find this vector length? So as I said, like a vector, so magnitude is just a fancy word of the length. So how we find the length of the vector? So how we find the length of the vector? So we use the Pythagoras theorem over there. So why we use Pythagoras theorem? So why we use Pythagoras theorem here? So I'll show you. Wait. So we are plotting this point like this. So we simply make this as a triangle. So this as a triangle. So my triangle is so bad. So this make so we make this as a triangle. So my triangle is so bad, but my hand is paining. So it's okay, no worries. Look. So this we make a triangle over there. So we make a triangle over there. So we can clearly say something known as this. So what do you mean by this? It's just a right angle triangle. Yes, it's just a right angle triangle. So there is something mysterious about the right angle triangle. So there is a formula like hypotenuse square is equal to adjacent square by opposite square, right? Adjacent square by opposite square. So we just simply substitute these points in our example and we get our length of the vector. So like for example, if if y is equal to 4 and x is equal to 4, for example, it's just a we are taking for an example, like okay, so we just substitute this over here and we simply get like 16 plus 16 and then we get 32. So we just the square it if it comes to the right side and it will become a root 2. So the what is the value of root 32? So what is the value of root 32? So just comment down below. So just comment down below with the timestamp which you are watching right now. So that I can know that my students are following. I hope you do that definitely. So okay. So so today's last topic is vector multiplication. So so there are two methods for the vector multiplication, which is dot product and with and what and the another one is cross product. So what do you mean by a dot product and a cross product? Just simply like we use just simple like, so what do you mean by a dot product? Okay, here we multiply vectors using the dot product. So we multiply the vectors using the dot product. This is called as dot product. So as I give a simple example, if if there is a vector A, if there is a vector A and a vector B, if we use the cross product over there, then it will become like into cos theta. So why the cos theta came? Why the cos theta came? It's just your job to so so as a dot product, like we just multiply the vectors using the dot product. Okay, so we simply have a formula over there. So like, so why we use cos theta over here? So why we use cos theta, or why we use, that is your job. That is your job. Just research about there and then comment down below, and comment down below, so that I also could know. I know the answer, but I want you to know. It's just simple like, so why we use cos theta in the in over here. I hope you do that and will come that. So it is all about combining the two vectors into a single number or a scalar. It tells about how much two vectors point into the same direction. So the vectors, so the dot product, that so the dot product shows, so the dot product tells that how much these two vectors, a vector and b vector, point out in the same direction. I hope you understand. Like, it tells about the two, it tells about the vector a and vector b point out in the same direction. So when the cos theta 0, if the cos theta is 0, if the cos theta is 0 degrees, then the cos 0 is equal to 1. Then the dot product will be the largest. And if the cos theta is 90 degrees, then it will become 0, and the dot product will be the smallest. And the small bit, it bit are confusing as of now, just I'll explain it again. Okay, so come to the cross product. So it tells how much two vectors point out in a different direction. So it tells how much two vectors point out in a different directions. So if the vectors are completely opposite, we have to use the cross product. So if the completely opposite means we have a 90 degrees out there. So if the vectors are completely opposite, then we use cos product. And we have a something as similar to the formula, like as previous, like a b, and here we have sine theta. So if the both are, if the theta has a 90 degrees, then it will become 1. Then the cross product will be the, then the cross product will be the largest. If the angle between these two will be the 0, then it will be the smallest. I hope you understand. Okay, if the vectors are in the same direction, then the dot product will be the largest. So if the vectors in a same direction, if the vectors are in the same direction, then the dot product will be the largest. Or if the vectors in opposite direction, then the cross product will be the largest. I hope you understand. Okay, so as I said, I will explain it again. So I'm explaining in brief. Okay, so what is dot product? So what is dot product? It just multiply the vectors using the dot products. It just multiply this vector. But we cross out this. We don't have the cross over there. We have dot product. We have dot over there. So we have dot. We can't simply, like, as we done before, like this directly. We have something, a formula, which is this. We have something formula which is this, and we calculate the dot product by using this formula. Okay, and it's all about the combining these two vectors into a single number. So I'm sorry. So it's all about combining the two vectors. If we do the problem over there, we get a scalar. The output will be the scalar. Okay, so it tells how much two vectors point out in a same direction. It tells how much the two vectors point out in a same direction. The cross product will deal. It tells out how much in a different direction. It tells how much in a different direction. Okay, so if the cos theta, as an example, like if the cos theta is 0, then it will be the largest. If the cos theta is 90, then it will be the smallest, because it has the opposite sides. If the cos product is 90, then we can't say that the dot product is the largest, because both are directing in a different direction. Okay, and then we're going to come with the cross product. As simple as this. Like, we in cross product, the the vectors are in a different direction. If the vectors are in different direction, then we use cross product over there, and then there it is the largest. If the vectors are completely opposite, as I said, like, we use the cross product. If the vectors are in the same direction, then we use the dot product. So I hope you understand. So why we need this? So in our further lectures, like, we when we cover the linear regression, etc., and we're going to use the dot product in our further lectures, in our further projects also. So we're going to use the dot product and the cross product in many applications, and many projects in the future. So I hope you just get it. So what is dot product? It uses dot, okay, with this formula, and what do you mean by cross product? What do you mean by cross product? Cross product means it also multiply same with, but we have a sin theta over here, we have a cos theta over there. So I hope you understand in a in a better way, in a best way. I tell my best way over here. So I hope you enjoyed this session. I hope you enjoyed this. So I hope you like this session. So until then, bye. So see you in a next lecture.